Hi, myself B. Ramesh, Assistant Professor in Mechanical Engineering Department, WITS Warangal. Welcome to WITS Connect. Okay, as earlier class we have discussed about the Porter governor and some of the problems on the Porter governor. Okay, and today's session we have discussed another governor is HARTNELL governor. Okay, na today's session lo HARTNELL governor gurinchi telusukundam. This is the HARTNELL governor. This is the diagram of HARTNELL governor. It will be consisting as spring loaded governor also. Okay, then one spring loaded governor and good atom. It is the combination of nut, frame, springs and balls. This is the collar and this is the sleeve and this is the total spindle. Okay, the total HARTNELL governor is based on the spindle. Okay, na man total governor is spindle meedane attach ayi untundi. Okay, here this is the roller. Okay, this is the roller. It is the used to the balls are moving towards the governor axis and away from the governor axis. అంటే మనకి balls అనేటి governor axis కి దగ్గర రావడానికి and governor axis నుంచి దూరంగా వెళ్ళడానికి we have to use the two rulers. Okay, and next one, this is the collar. We are attached the weights and this is the sleeve weight. Okay, మనం ఎంత weight apply చేస్తామో ఇక్కడ attach చేసుకోవచ్చు. And this is the total spindle and these two are the balls. Okay, these two are all the balls. Okay, this is the total frame, this is the spring loaded. This is about the HARTNELL governor. Here we can draw the in minimum condition position and maximum condition position. Okay na, మనం minimum condition position లో HARTNELL governor ఏ విధంగా వర్క్ చేస్తుంది and maximum position condition లో HARTNELL governor ఏ విధంగా వర్క్ చేస్తుందో we have to draw the in this line diagram. Here this is the minimum position. Okay, this is the minimum position. Okay, here this is the maximum position. Maximum position. Okay, this is the minimum position, this is the maximum position. Okay, madam, we have see the first one, the minimum position. Here the speed of the governor is very low. Okay na, the speed of the governor is very low. Then the balls are attached then the balls are moved to the towards the governor axis. Okay na, మనకి ఏమవుతుంది, the balls ఏమవుతుంది, ఈ two balls are అనేది మనకు governor axis కి towards center కి మూవ్ అవుతాయి. అప్పుడు మనకు the minimum position condition లో HARTNELL governor యొక్క speed of the governor ఏ విధంగా ఉంటుంది. Here this is the way obtained from the centrifugal force, that is Fc1, this is the B and mg. Okay, mass of weight. Okay na, మనం బాల్ యొక్క weight ఎంత ఉంటుందో that will be m into g. This is the distance from the r1 is nothing but this is the distance from the మన roller axis to the center of the ball. Okay, that is r1. This is the total abbreviation of the HARTNELL governor. Okay, m is nothing but mass of the ball. Okay na, ball యొక్క mass ఎంత ఉంటుంది, mass of ball in kg. Okay na, mass of ball in kg. Small m is weight of the sleeve. Okay na, మన దేని యొక్క weight ఇది, ఈ sleeve యొక్క weight, mass of weight, mass of sleeve, sorry. Okay, mass of sleeve in kg. Okay, small m is mass of ball, capital M is mass of sleeve. Okay, ఈ sleeve యొక్క mass ఎంత ఉంటుంది. Again next r1. Okay, r1 అంటే this is the r1. Okay, this is the r1. The distance r1 is nothing but minimum radius of rotation. Okay, minimum radius of rotation. ఎంత minimum position లో ఎంత radius of rotation జరుగుతుంది బాల్ అంటే r1 is minimum radius of rotation in meters. Okay, minimum radius of rotation in meters. As well as same position లో r2 కనుక చూసుకుంటే this is the r2, this is the maximum radius. Okay na, when the maximum position, the మనకేమవుతుంది, when the HARTNELL governor are at maximum speed, the two balls are away from the governor axis. మనకేమవుతుంది, two balls అనేది governor axis నుంచి దూరం వెళ్ళి rotate అవుతూ ఉంటుంది. Okay, here r2 is the distance between the maximum position లో HARTNELL governor ఎంత distance లో rotate అవుతుందో, that is the r2, roller axis to the ball axis. Okay, that is the maximum radius of rotation. Maximum radius of rotation in meters. Okay, in meters, maximum radius of rotation in meters. Okay, next one, omega 1 is nothing but angular speed of the governor. Okay, omega 1 is angular speed of governor, okay, in minimum position. Okay, na, in minimum position. Okay, angular speed of the governor in minimum position. Okay, ఇందులో వస్తాయి మనకు ఒమేగా అంటే 2πn/60 గా మనం అక్కడ నుంచి మనకు ఆల్రెడీ స్పీడ్ తెలుసు కాబట్టి we will find out the angular speed of the governor at minimum position, and omega 2 is angular speed of the governor at maximum position. Okay, now we know the maximum position at here we obtain the n2 value, but that is speed of the maximum position teliste manaku we can find out the omega 2 2πn/60. Okay, next s1 is nothing but spring force extracted on the sleeve at omega. Okay, na, spring force మనకి ఇక్కడ ఉంది కదా, ఈ spring force ను extract చేయాలి ఎప్పుడు at angular speed of the minimum position ఉన్నప్పుడు. Okay, na, spring force, this one is spring force extracted on the sleeve. Okay, spring force extracted on the sleeve at angular at minimum position. Okay, na, spring force at minimum position. And omega s2 is nothing but spring force extracted on the sleeve. Okay, na, spring force ఎంత ఎక్స్ట్రాక్ట్ అవుతుంది ఈ స్లీవ్ నుంచి. ఓకే, స్లీవ్ మన ఈ స్లీవ్ నుంచి స్ప్రింగ్ అనేది ఎంత ఫోర్స్ ని ఎక్స్ట్రాక్ట్ చేస్తుంది. ఓకే, స్ప్రింగ్ ఫోర్స్ ఎక్స్ట్రాక్టెడ్ ఆన్ ది స్లీవ్ అట్ ఒమేగా 2. ఓకే, స్ప్రింగ్ ఫోర్స్ at maximum position. Okay, na, how much amount of spring is extracted from the force on the sleeve, ఎంత amount of force అనేది extract చేసుకుంది sleeve నుంచి, అది that is s2. we are new units ఏంటి మనకు, it will be newtons, this is also newtons. fc1, we know the fc1, that is the centrifugal force this is also centrifugal force at minimum condition, centrifugal force at minimum condition, centrifugal force at maximum condition. S is nothing but a stiffness of the spring. S ante stiffness of the spring. Okay, no? S ante we know the S value, that is stiffness of the spring. Then next we will find out the derivation find out we will find out the stiffness of the spring. Enta spring oka stiffness ఎంత ఉందో we will find out. X is, and X ante general ga manaku the X is the length of the vertical. Okay, na, vertical ఈ distance నుంచి మన O point నుంచి B point వరకు ఎంత distance ఉందో that is the length of the vertical. Okay, length of the vertical position, ఇది length of the horizontal position. Okay, x is nothing but the height of the vertical height లో ఎంత డిస్టెన్స్ ఉందో దాన్ని మనం x తో డినోట్ చేస్తాం, అండ్ హారిజాంటల్ గా ఎంత ఉందో దాన్ని మనం y తో డినోట్ చేస్తాం. ఓకే, దీస్ ఆర్ ది టోటల్ అబ్రివియేషన్ ఆఫ్ ది ఇన్ మినిమం కండిషన్ అట్ మాక్సిమం కండిషన్. మినిమం కండిషన్ లో కనుక చూసుకుంటే the force that is the mg, weight equals w equals to mg తో ఇండికేట్ చేస్తాం. Here some amount of force is acting on the roller, that is mg plus s1/2. s1 is nothing but spring force extracted from the angular speed. Okay na, spring force extracted from the sleeve. ఈ స్లీవ్ నుంచి ఎంత ఫోర్స్ అనేది ఎక్స్ట్రాక్ట్ చేసుకుంది ఎప్పుడు at a minimum condition, that is weight plus spring force divided by 2. Okay, and next r1 is roller, this is the height h1 అంటే మనకు మినిమం కండిషన్ లో మనకు గవర్నర్ అనే హైట్ అనేది ఎంత డిస్టెన్స్ కి మూవ్ అవుతుంది, that is h1, and this is the angle of theta. ఓకే, మన ఆర్మ్ యొక్క లెంత్ దీని మధ్యలో యాక్సిస్ నుంచి ఆర్మ్ కి ఎంత డిస్టెన్స్ యాంగిల్ ఉందో that is the theta, and next this is the x, and this is the total r1, ఇక్కడ నుంచి ఇక్కడ ఎంత డిస్టెన్స్ ఉందో r1, and this is the sa1. in the same condition లో మనకు this is the r2 a2 r value, and this is the mg, that is the మనకు బాల్ నుంచి ఎంత వెయిట్ అప్లై అవుతుందో, and next this is the theta angle at maximum position. స్పీడ్ మనకి ఏమవుతుంది, బాల్ అనేది గవర్నర్ యాక్సిస్ నుంచి దూరంగా వెళ్తుంది కాబట్టి here we get the మన రూలర్ it moves the upward side. Okay na, s2 అంటే మనకు జనరల్ s2 is nothing but the spring force extracted from the sleeve at a maximum position. Okay, this is the minimum position, and this is the maximum position. Here we derive the one formula of the stiffness of the spring. Here we derive the stiffness of the spring. Okay, first one for minimum position. Okay, for minimum position, that is when the radius of rotation, that is r. Okay, na first condition unnappudu radius of rotation, that is r, it will be changes to the r1. r nunchi manaku r1 ki change అయినప్పుడు the comparison of spring lift of this sleeve ఎంత comparison అవుతుందో చూద్దాం. Okay, here sleeve, that is sleeve h1. Okay, that is the sleeve h1. Here h1 by y is equals to a1 by x. Okay, here sleeve h1, height of the sleeve, that is h1 is equals to h1 by y equals to a1 by x. Here a1, okay, now manaki a1 ravalante here a1 is nothing but a1 ఎలా వస్తుంది, that is r minus r1. Okay, h1 by y is equals to here a1 place లో ఏం రాసుకుంటున్నా, here a1 రావాలంటే మనకు here total r minus r1 గా రాసుకోవచ్చు. ఇక్కడ a1 place లో r minus r1 by x. Okay, here this is the one of the equation. And next for maximum position, here we get the minimum position. This is the minimum position. Next maximum position. Here we get the maximum position when the radius of rotation, r will be changes, r2 వరకు చేంజ్ అవుతుంది, r నుంచి r2 కి చేంజ్ అవుతుంది. Here we get the sleeve h2 is nothing but ఈ sleeve h2 by y2. Okay, h2 by y, general గా we know the y, only we take the y equals to e2 by x. Okay, this is the another form in maximum position. Here we get the a2 value. Here we get the a2 value is equals to r2 minus r. Okay, na total r aithe manaku r2 minus r cheste we get the a2 value. Okay, a2 is equals to h2 by y is equals to a2 place we have write the r2 minus r divided by x. Okay, na this is the second equation, this is the first equation. Here adding equation 1 and 2. Okay, na two equation ni manam add chedam, adding equation 1 and 2. Okay, here we get the equation, that is the h1 plus h2 by y, h1 plus h2 by y is equals to r2 minus r1 divided by x. Okay, here we get the h1 is equals to h2 is equals to h. Okay, now h1 equals to h2 equal to h గా తీసుకుంటే మనం, లేదా h is equals to h1 plus h2 గా తీసుకుంటే, height of the governor is equals to h1 plus h2 గా కనుక తీసుకున్నట్లయితే here h by y is equals to r2 minus r1 divided by x గా మనం రాసుకోవచ్చు. Here finally h is equals to r2 minus r1 by x into y. This is the another equation, this is the third equation. Okay, here we found the third equation. Next, now we take from the minimum position. Okay, na minimum position lo return manaku ఏ విధంగా అవుతుంది, minimum position taking moment about the point of O. Okay, మనం minimum position లో taking moment point of O నుంచి తీసుకుంటే we get the one of the equation, that is at minimum condition, minimum position. Okay, at minimum position taking moment about the O, then we get the one of the equation, that is mg by 2 plus s1, mg by 2 plus s1 into mg by 2 plus 1 into, that is y1 into y1. y1 is nothing but this is the y1, the distance between the O to R, molar nunchi O ki madhya unna distance, is equals to, we obtain the centrifugal force F1, into x1, Fc1 into x1, the height of the ball. Okay, na? x1 minus mg into a1 minus mg into a1. Here we get from this value plus s1 is equals to mg plus s1 equals to 2 by y1 గా రాసుకోవచ్చు. దీన్ని అది తీసుకెళ్తే మనం 2 by y1 into fc1 into fc1 into x1 fc1 into x1 minus mg into a1. Okay, minus mg into a1 గా రాసుకోవచ్చు. Okay, this is the fourth equation. Okay, this is the fourth equation at a minimum position, the taking moment about the O. Next here the maximum position and the taking moment about O. For minimum position, this is the maximum position. Here same value, that is mg plus s2 by 2 into here we get the y2. Okay, here we get the y1, here we get the y2 at the maximum position equals to fc2 centrifugal force at the maximum position into x2. Okay, here into x2 is nothing but the distance between the O to point of ball point B వరకు మనకు ఉన్న distance, that is the x2 plus mg into a2. Okay, here same manner mg plus s2 is equals to 2 by y2 fc2 into x2 plus mg a2. Okay, here this is the another equation, fifth equation. This is the fourth equation. Okay, from this fourth equation and fifth equation we form the next fourth equation and fifth equation. We subtracting the equation 4 from the equation 5. Okay, equation 4 from the equation 5, then we get the value of s2 minus s1 is equals to 2 by y2 into fc2 2 by y2 into fc2 into x2 fc2 into x2 mg plus mg a2 plus mg a2 minus 2 by y1 into fc1 into x1 plus mg a2. Okay, మనం ఏం చేస్తున్నాం, equation 4 equation 5 minus equation 4 గా చేస్తున్నాం. Here we know that s2 minus s1 equals to h into s. s2 minus s1 equals to h into s, and here h is equals to r2 minus r1 into x by y. Okay, x by y. Here substitute s equals to s2 minus s1 by h. Okay, s equal to s2 minus h1 by s. Here substitute the h value in this form. Okay, then we get the s equals to s2 minus s1 divided by r2 minus r1 into here h equals to y by x. Then we get the y by x by y. Okay, and then next, neglecting the effect of arms, then we take the, that is neglecting the effect of the arm తీసేస్తే మనకు x1 equals to x2 equals to x అవుతుంది. అంటే x1 is equals to x2 is equal to మనం x గా తీసుకుంటున్నాం, and y1 equals to y2 equals to y గా తీసుకుంటున్నాం, y1 equals to y2 equals to y గా తీసుకుంటున్నాం. Okay, and the momentum due to weight of the ball, we have the minimum position లో కనుక చూసుకున్నట్లయితే here minimum position. Okay na, at a minimum position, ఈ minimum position లో కనుక చూసుకుంటే then we get the formula of, ఇక్కడ minimum position ఇలా రాసాం కదా, దెన్ ఇక్కడ ఏమవుతుంది x1 ఈక్వల్స్ టు x2 ఈక్వల్ టు x గా రాస్తున్నా, y1 ఈక్వల్స్ టు y2 ఈక్వల్స్ టు y గా రాస్తున్నా. ఓకే, హియర్ mg/2 plus s1 mg/2 plus s1 into y is equals to fc1 into x గా రాసుకుంటున్నాం. ఓకే, mg/2 plus s1 into y fc into x గా రాసుకుంటున్నాం. అండ్ నెగ్లెక్టింగ్ ద mg and ఈ వాల్యూని నెగ్లెక్ట్ చేస్తున్నాం. అట్ మినిమం పొజిషన్ కండిషన్ లో ఇక్కడ mg plus s1 is equals to 2 by y into fc1 into x గా రాసుకుంటున్నాం. హియర్ దిస్ ఈస్ ద 6th ఈక్వేషన్. ఓకే, ఇలా ఫార్మ్ చేసుకుంటున్నా. అట్ మాక్సిమం కండిషన్ లోకి వెళ్తే దిస్ ఈస్ ద మినిమం పొజిషన్. నెక్స్ట్ maximum position, and here we write the maximum position, that is mg/2 plus s2 into y equals to fc2 into x గానే రాసుకుంటున్నా. అండ్ ఎందుకంటే బికాస్ ఆఫ్ x1 ఈక్వల్స్ టు x2 ఈక్వల్స్ టు x and y1 ఈక్వల్స్ టు y2 ఈక్వల్స్ టు y గా రాసుకుంటున్నా. Here then we form the equation mg plus s2 is equals to 2 by y into fc2 into x గా రాసుకుంటున్నాం. ఓకే, here from the another equation, this is the 7th equation. Okay, this is the 7th equation. Subtracting equation 6 from equation 7. Okay, subtracting equation 6 from equation 7, then we get the value of s2 minus s1. Here is s2 minus s1, and s2 minus s1 is equals to 2 into fc1 minus 2 into fc2. fc2 minus fc1 into x by y. Okay, now here we get the value of s2 minus s1. Okay, s2 minus s1 is equals to 2 by y into fc2 minus fc1 into x by y. Okay, here we know that the value of, this is the 8th equation. Here we know the value of s2 minus s1 equals to h into x. We know that equation. Here s equals to s2 minus s1 by h గా రాసుకుంటున్నా. Here h value equals to, h value మనకు తెలుసు కదా ఆల్రెడీ, that is r2 minus r1 into y by x. Okay, r2 y by x. Here s equals to s2 minus s1 by h. h value అవుతుంది r2 minus r1 minus y by x గా రాసుకుంటున్నా. Here substituting h value in this equation. Okay, h value in this equation లో substitute చేస్తే మనకి ఏమవుతుంది, h value ని s equals to s2 minus s1 divided by r2 minus r1 into x by y గా రాసుకోవచ్చు. ఓకే, s2 minus s1 divided by r2 minus r1 into x by y గా రాసుకోవచ్చు. Here the substituting all these values in this equation, then we get the value of s equals to 2 into మనకి ఏమవుతుంది ఇక్కడ fc2 minus fc1 divided by r2 minus r1 into x by y whole square గా మనకు ఈక్వేషన్ అనేది ఫామ్ అవుతుంది. This is the one of the equation of stiffness of the spring of HARTNELL governor. Okay, in this manner we derive the stiffness of the spring of HARTNELL governor. Okay, and next class we have discussed about the some of the problems on the HARTNELL governor. Okay, thank you.